The date was March 21, 1944, and Oberleutnant Franz Stigler had spent 8 months hunting American heavy bombers. He knew his business well. His method was practiced and deadly. Approach swiftly from behind, exploiting the vulnerable area under the tail section, concentrate fire on engines or fuel systems, then escape before defensive gunners could track his position. 3 flying fortresses had already fallen to this exact technique. The American bombers were impressive machines, carrying 13 heavy machine guns and flying in tight groupings that created interlocking defensive coverage. But German fighter pilots had developed countermeasures. Strike from directly ahead and above where nose armament had limited movement. Come in from behind and below where belly turrets couldn't effectively engage. Use speed advantage to close distance rapidly, fire accurately, and break away before concentrated return fire could be brought to bear. Stigler pushed his throttle forward and began his approach. As the distance closed to 5 kilometers, something seemed unusual. These weren't flying fortresses. The fuselages appeared longer, wings positioned differently on the body. The tail assembly was distinctive, featuring twin vertical stabilizers rather than the single tail structure of the fortress. These were Liberators. Stigler had heard discussions about them from other pilots, but this marked his first direct encounter. He maintained his approach, computing angles and deflection mentally. The formation held steady course, continuing their bombing approach toward the manufacturing facility at Augsburg. Stigler positioned himself for his standard attack from behind and below, the method that had proven so effective against fortresses. Perhaps 2,000 meters separated him from the trailing aircraft when the first tracer rounds reached toward his position. Then came additional streams of heavy caliber fire from multiple locations, not merely from the tail position, but from side positions, from underneath, seemingly from every angle of the aircraft. The sheer volume of fire was staggering. Stigler broke left, diving away as his aircraft shuddered from several impacts on his wing. He had never experienced defensive fire of such intensity from a single bomber. On the ground below in the operations room, intelligence officers were gathering reports that would fundamentally alter German understanding of American bomber capabilities. The Liberator wasn't simply another heavy bomber. It was a flying weapons platform with firepower exceeding even the Fortress, and the Americans were manufacturing them in quantities, suggesting the daylight bombing offensive was about to intensify beyond anything Germany had yet faced. The question haunting German fighter commanders over subsequent months wasn't whether they could destroy Liberators, it was whether they could sustain the losses required to do so, because each Liberator carried 10 heavy machine gun positions, and the Americans had constructed more than 18,000 of them. To comprehend why the defensive armament represented such a shock to German pilots, one must first understand the development of German fighter tactics against heavy bombers. When American daylight bombing operations began seriously in 1942, German air forces approached the problem with confidence derived from years of air combat experience. German fighter doctrine emphasized speed, firepower, and aggressive tactics. The backbone fighter could reach speeds exceeding 600 km per hour. It mounted a 20mm cannon firing through the propeller hub and to 13mm machine guns synchronized to fire through the propeller arc. Later versions added to more 20mm cannons in underwing mountings. This was devastating firepower designed to destroy enemy aircraft quickly. The fundamental German approach to bomber interception was straightforward. Fighters would attack in groups, for aircraft formations approaching from angles that minimized exposure to defensive fire. The preferred attack came from directly ahead and high, diving through the bomber formation with all weapons firing, then using speed to escape before defensive gunners could respond effectively. Alternative attacks came from behind and low, exploiting blind spots in the bomber defensive coverage. These tactics had proven effective against British bombers during earlier campaigns. British bombers typically carried 4 to 8 machine guns in powered turrets. German fighters could close quickly, fire concentrated bursts, and break away with acceptable risk. The doctrine worked. German pilots destroyed hundreds of British bombers using these methods. When American flying fortresses began appearing over Europe in 1942, German pilots initially treated them as simply another heavy bomber. This assessment proved costly. The fortress carried 13 heavy-caliber machine guns in multiple positions, 2 in the nose, 2 in the upper rotating turret, 2 in the ball turret beneath the fuselage, 2 in the tail, 2 at the side positions, and 1 in the radio compartment. The defensive firepower substantially exceeded anything German pilots had previously encountered. More importantly, the Americans flew in tight formation boxes, specifically designed to create overlapping fields of fire. A fighter attacking one bomber would be exposed to defensive fire from multiple aircraft simultaneously. German pilots discovered that casual approaches resulted in damaged aircraft and dead pilots. German air forces adjusted tactics accordingly, identifying specific attack angles where defensive fire was less concentrated, developing techniques for rapid closure and breakaway, and emphasizing coordinated attacks that overwhelmed the bomber defensive capability. By early 1944, German fighter units had developed a reasonable understanding of fortress vulnerabilities and attack methods that, while dangerous, offered acceptable odds of success. Experienced pilots knew where to attack, how to manage their approach speed, and when to break off. The learning had been expensive, paid for in damaged aircraft and casualties, but German fighter units believed they had adapted to the American daylight bombing threat. They were about to discover how mistaken that assumption was. The Liberator emerged from a 1938 requirement for a heavy bomber with greater range, higher speed, and better high-altitude performance than existing designs. The specification called for an aircraft capable of carrying 8,000 pounds of bombs over 3,000 miles at speeds exceeding 300 miles per hour. The manufacturer approached the challenge with innovative engineering. The chief designer developed an aircraft around a high aspect ratio wing design that provided exceptional lift-to-drag characteristics. The wing mounted high on the fuselage gave the aircraft its distinctive appearance and contributed to its superior range and fuel efficiency compared to other heavy bombers. The prototype first flew on December 29, 1939. It demonstrated performance exceeding expectations. Maximum speed reached 313 miles per hour. Service ceiling exceeded 30,000 feet. Most importantly, range with a 5,000-pound bomb load exceeded 3,000 miles. These capabilities made the aircraft ideal for long-range strategic bombing missions, but range and speed were only part of the design philosophy. Designers had learned from early war reports that heavy bombers operating over hostile territory did substantial defensive armament. German and British experience demonstrated that unescorted bombers faced devastating losses without adequate defensive firepower. The designers incorporated this lesson from the beginning. Early production models entering service in 1942 carried 10 heavy-caliber machine guns, 2 guns in the nose manually aimed by the bombardier, 2 in a powered upper turret positioned behind the cockpit, 2 in a powered ball turret beneath the fuselage, 2 in the tail turret, and 2 at side positions, 1 on each side of the rear fuselage, manually operated by side gunners. The heavy-caliber weapon was itself formidable. Designed in the 1920s and perfected through the 1930s, it fired a projectile on a muzzle velocity of approximately 2,900 feet per second. Rate of fire reached 750 to 850 rounds per minute per gun. Each gun position carried between 300 and 600 rounds of ammunition, depending on location. The ammunition itself came in several types. Standard rounds for general use against aircraft structures. Armor-piercing incendiary rounds designed to penetrate armor plate and ignite fuel. Tracer rounds for aiming correction. A typical ammunition load mixed these types, usually 4 armor-piercing incendiary rounds to 1 tracer round in repeating sequence. This combination gave gunners both destructive power and visual feedback for aim correction. The effectiveness of the defensive armament didn't come from any single innovation, but from the comprehensive integration of multiple systems designed to create overlapping fields of fire that left virtually no approach angle undefended. American engineers had studied combat reports from both British and early American bombing missions to identify where defensive gaps existed and how attacking fighters exploited them. The nose position consisted of two weapons mounted in flexible sockets operated by the bombardier. These guns could traverse approximately 60 degrees left and right and elevate to cover threats approaching from directly ahead and high, the classic fighter attack angle. The bombardier, lying prone in the nose compartment with the bomb sight, could quickly transition from bombing duties to defensive gunnery when enemy fighters appeared. The powered turrets represented significant technological achievement. The upper turret position just behind the cockpit rotated 360 degrees and could elevate to nearly vertical. Two weapons fired in unison, controlled by the turret gunner through a computing gun sight that calculated lead angles based on target speed and direction. The turret electric motors could traverse at 60 degrees per second, fast enough to track most attacking fighters. The ball turret beneath the fuselage was perhaps the most remarkable defensive position. A spherical housing containing two weapons and a gunner suspended from the aircraft belly by a support frame. The gunner, typically the smallest crew member due to space constraints, entered through the fuselage and was then rotated into position. Once sealed inside, he operated in a space barely 4 feet in diameter, surrounded by ammunition feeds, gun mechanisms, and the thin aluminum skin separating him from outside air at 25,000 feet. The ball turret could rotate 360 degrees and elevate from directly downward to nearly horizontal forward. This gave complete coverage of the lower hemisphere, eliminating the blind spot that German fighters had exploited when attacking fortresses from behind and low. The computing sight automatically calculated deflection angles, allowing even relatively inexperienced gunners to achieve effective fire against fast-moving targets. The tail turret provided rearward defense with two weapons in a powered mounting. The tail gunner, isolated in the rear fuselage, had perhaps the most dangerous position on the aircraft. He faced backwards throughout the mission, watching 4 fighters approaching from astern. When attacks developed, he was the first line of defense, engaging fighters as they closed from behind. The tail turret could traverse approximately 90 degrees horizontally and 60 degrees vertically, covering the entire rear quadrant. The side positions, one on each side of the rear fuselage, were manually operated by side gunners. These positions initially had open windows through which the guns fired, exposing gunners to extreme cold and wind at high altitude. Later models enclosed these positions, but the guns remained manually aimed and fired. Side gunners covered the beam approaches, engaging fighters attacking from either side. Their fields of fire overlapped with both the upper turret and ball turret, creating zones where attacking fighters faced fire from multiple positions simultaneously. Each gun position carried substantial ammunition. The nose guns had approximately 600 rounds per gun. The upper turret carried 400 rounds per gun. The ball turret, limited by space constraints, held 580 rounds per gun. The tail turret carried 600 rounds per gun. The side guns each had 600 rounds. Total defensive ammunition load exceeded 6,000 rounds, weighing approximately 400 pounds. The guns themselves were meticulously maintained. Armorers cleaned and inspected each weapon before every mission. They checked mechanisms and timing, ensuring the guns would fire reliably at altitude where temperatures could reach 60 degrees below zero. They loaded ammunition belts, mixing armor-piercing incendiary and tracer rounds in the proper sequence. They test-fired each gun on the ground when possible, verifying function. The first large-scale encounter between German fighters and Liberator formations occurred during an August 1943 raid. 177 aircraft launched from bases in Libya to attack Romanian oil refineries that supplied much of Germany's fuel. The mission required flying at extremely low altitude to achieve surprise, negating much of the bomber defense advantage. German and Romanian fighters engaged the formations throughout the attack. The results were devastating for both sides. 54 bombers were lost, mostly to anti-aircraft fire and collisions with obstacles during the low-level attack, but German fighters claimed several kills. However, German pilots reported something unexpected in their debriefing sessions. The bombers, even at low altitude where their defensive positions had restricted fields of fire, generated massive volumes of fire. Multiple German fighters returned to base with significant damage. Several pilots were killed or wounded by defensive fire. One decorated fighter ace with over 100 confirmed victories filed a combat report after engaging bombers during this mission. He described approaching a damaged bomber that had separated from the formation, intending to finish it with a standard rear quarter attack. As he close to firing range, he encountered what he described as a wall of tracers from multiple positions on the aircraft. His fighter took several hits, damaging his engine and forcing him to break off. The bomber, despite visible damage and flying alone, successfully defended itself and limped toward friendly territory. But this was an anomaly. A low-altitude mission, unlike the high-altitude strategic bombing that would characterize the air war over Europe. The true test came during the sustained bombing campaign of late 1943 and early 1944, when Liberator groups joined fortress groups in massive formations attacking targets deep inside Germany. On October 14, 1943, American forces launched a mission against ball-bearing factories. The force included 291 fortresses and 29 Liberators. German fighters attacked in waves throughout the mission. The Americans lost 60 bombers, most of them fortresses. The Liberator groups flying slightly different altitudes and routes reported lower loss rates despite flying through the same defended airspace. Post-mission analysis revealed significant differences in how German fighters approached Liberators versus fortresses. German pilots experienced in attacking fortresses initially used their standard tactics against Liberators. They quickly learned these tactics were less effective. The ball turret complete lower hemisphere coverage eliminated the blind spot from behind and below. The nose guns and upper turret created devastating fire zones for frontal attacks. The side positions with their broad fields of fire made beam attacks extremely dangerous. German pilots began developing new tactics specifically for Liberators. Intelligence officers interrogated captured German pilots and compiled their observations. One pilot shot down, Breeze fighter, was damaged attacking a Liberator formation, described the experience to American interrogators. He had attacked what he thought was a standard heavy bomber formation from the side. A beam approach. As he close to 400 meters, fire from at least 4 different positions on multiple aircraft converged on his fighter. His engine was hit, his canopy shattered, and he suffered wounds to his left arm and shoulder. He managed to bail out before his aircraft entered an uncontrollable spin. What struck him most, he told interrogators, was the sheer volume of fire. He had attacked fortress formations many times using similar tactics. The defensive fire from fortresses was substantial but manageable. Experienced pilots learned to minimize their exposure and accept reasonable risk, but the Liberators seemed to fire from every angle simultaneously. The concentration of tracers was unlike anything he had experienced. He stated flatly that he would not attack Liberator formations using beam approaches again. The statistical evidence compiled by both German and American intelligence confirmed what individual pilots were reporting. Liberator formations were more difficult to attack successfully than fortress formations, and German fighter losses per bomber destroyed were higher when engaging Liberators. American statistical analysis from late 1943 through early 1944 documents this disparity. Fortress groups flying missions during this period experienced loss rates averaging approximately 5% per mission, sometimes higher during particularly intense fighter opposition. Liberator groups flying similar missions to similar targets experienced average loss rates of approximately 3.8%. The difference appeared small in percentage terms but became significant when calculated across hundreds of missions and thousands of aircraft. German records captured after the war and analyzed by intelligence revealed corresponding patterns. German fighter units reported higher ammunition expenditure per Liberator destroyed compared to fortresses. The average fighter required approximately 3 to 4 attack passes to destroy a fortress flying in formation. Destroying a Liberator in formation at an average of 5 to 6 passes, exposing the attacking fighter to defensive fire for substantially longer periods. More tellingly, German fighter loss and damage rates increased when engaging Liberator heavy formations. Combat logs documented this clearly. During January 1944, one unit engaged American bomber formations on 17 separate occasions. 8 engagements were primarily against fortress formations. 9 were primarily against Liberator formations. The unit lost 12 aircraft destroyed and 19 damaged during the month. Of the 12 aircraft destroyed, 8 were lost during engagements with Liberator formations. Of the 19 damaged, 13 occurred during Liberator engagements. The disparity became stark when commanders analyzed the data. Their fighters were suffering higher losses despite achieving fewer bomber kills when attacking Liberators. The mathematics were unfavorable. If current trends continued, they would attrit their fighter force faster than they could replace it. The reason lay in the defensive architecture. The 10-gun positions created overlapping fields of fire that forced attacking fighters to penetrate multiple defensive zones. A fighter attacking from directly ahead and high-faced nose guns, upper turret guns, and potentially side guns if approaching at an angle. A fighter attacking from behind face-tail guns, upper turret guns, and ball turret guns. A beam attack from either side exposed the fighter to upper turret, ball turret, and side guns simultaneously. The effective range of the weapons exceeded 1,000 yards under ideal conditions, although practical combat range was typically -100 to 800 yards, where gunners could accurately track and lead targets. This meant attacking fighters entered the defensive fire zone while still outside their own effective cannon range. German cannons had maximum effective range of approximately 700 meters against bomber-sized targets. Larger cannons, introduced on later fighter models, extended this to perhaps 850 meters, but these ranges assumed steady accurate fire, difficult to achieve, while maneuvering violently and surrounded by defensive tracers. German fighter commanders recognized they faced a fundamental problem. The Liberator defensive firepower required tactical changes that their pilots, trained and experienced in methods that worked against fortresses, found difficult to implement under combat conditions. The German Air Force was fighting a learning war where each lesson cost aircraft and pilots they could not easily replace. A decorated fighter ace commanding a fighter wing issued new tactical directives to his pilots in February 1944. Pilots were instructed to avoid beam attacks entirely, unless no other approach was possible. The preferred attack angle shifted to directly ahead and high, diving through the formation at maximum speed to minimize exposure time. Alternatively, pilots should attack from behind and high, using altitude advantage to engage briefly before breaking away upward out of the ball turret field of fire. These tactics reduced German losses, but also reduced effectiveness. High-speed diving attacks gave pilots only seconds to aim and fire. The closure rate exceeded 500 miles per hour when combining the fighter speed with the bomber forward motion. Accurate gunnery under such conditions required exceptional skill. Most attacks resulted in misses or minor damage, rather than catastrophic hits. The alternative approach, from behind and high, forced fighters to attack through concentrated fire from tail guns and upper turrets, often from multiple bombers simultaneously, as formations maintained tight defensive boxes. Some German fighter units experimented with standoff weapons to avoid close engagement entirely. A rocket mortar launched from tubes beneath the fighter wings could engage bomber formations from beyond defensive gun range. Each rocket contained 110 pounds of high explosive equipped with a time fuse. Pilots fired salvos into the bomber formations, hoping for proximity detonations that would damage or destroy aircraft. The system proved largely ineffective. The rockets were inaccurate, their ballistic trajectory difficult to calculate under combat conditions. American bomber formations learned to break their tight boxes when they detected rocket launches, dispersing before the rockets arrived. Of thousands of rockets fired, only a handful of bombers were destroyed. The rockets added weight and drag to the fighters, reducing their performance during subsequent conventional attacks. Most fighter units abandoned the system after limited trials. The more effective German response was to concentrate overwhelming force against specific bomber formations. Rather than dispersing fighters across multiple attack axes, controllers directed entire wings against single bomber groups. 50 to 80 fighters attacking simultaneously could saturate even the Liberator formidable defensive fire. Achieving kills before the bomber mutual support could be fully effective, but this tactic required precise coordination, radar guidance to intercept the formations, and sufficient fighters to generate the necessary mass. As the air war progressed into mid-1944, German forces increasingly lacked all three requirements. German fighter production actually increased during 1944. Factories produced thousands of fighters in substantial numbers, but production could not overcome pilot losses. Experienced fighter pilots, men with years of combat experience and dozens of kills, were being shot down faster than training schools could replace them. New pilots arrived at operational units with perhaps 150 hours of flight time compared to 300 or more hours for pilots who had entered service in 1942. These inexperienced pilots faced American bomber formations defended by 10 weapons per aircraft, flying in boxes of 18 to 27 bombers that created overlapping defensive fire encompassing hundreds of guns. The new pilots died quickly, often on their first or second missions. By spring 1944, the average German fighter pilot life expectancy after reaching an operational unit was measured in weeks. The Liberator contribution to this attrition was substantial, but not immediately obvious in combat reports. The aircraft didn't generate dramatic moments. Instead, it steadily damaged attacking fighters, forcing them to break off, degrading their effectiveness, and occasionally achieving kills when damaged fighters couldn't return to base. Over hundreds of missions involving thousands of bombers, this cumulative effect eroded German fighter capabilities. The broader context of production, the true impossibility of Germany's strategic position. While German pilots struggled to develop tactics against American heavy bombers, American factories produced those bombers in quantities that rendered individual tactical victories meaningless. The industrial disparity between the United States and Germany was so vast that the outcome was predetermined regardless of tactical innovation or pilot courage. The manufacturer operated 5 production facilities building bombers. The main plant where the design originated produced aircraft steadily throughout the war. One motor company built a massive plant specifically for production. This facility, designed specifically for this purpose and funded by the government, was the largest manufacturing building in the world when completed in 1942. The main assembly building covered 67 acres under one roof. The assembly line stretched more than 1 mile. At peak production in 1944, this plant produced 1 complete bomber every 63 minutes. Workers, many of them women who had never worked in manufacturing before the war, assembled aircraft using mass production techniques adapted from automobile manufacturing. The plant employed 42,000 workers across multiple shifts operating 24 hours per day, 7 days per week. Additional plants also produced bombers under license. These facilities added thousands more aircraft to the production total. The entire production system represented an industrial mobilization unprecedented in human history, from first flight in December 1939 to final production in May 1945. American factories built 18,482 Liberators. This made it the most produced American military aircraft of World War II, exceeding even the Flying Fortress. Production peaked in 1944 when factories delivered 8,000 aircraft, an average of more than 20 aircraft per day, throughout the entire year. Each bomber required approximately 450,000 individual parts. The supply chain delivering these components involved thousands of subcontractors across the United States. Engines came from major manufacturers, propellers from specialized companies, instruments from precision manufacturers, weapons from arms producers, tires from rubber companies, radio equipment from dozens of electronics manufacturers. The organizational complexity, called the aircraft technical complexity, Germany could not match this production capacity. Total German four-engine heavy bomber production from 1939 through 1945 numbered fewer than 2,000 aircraft, including multiple types that never reached operational status. Germany produced excellent twin-engine medium bombers in substantial numbers, but these lacked the range, bomb load, and defensive armor of American heavy bombers. More critically, German aircraft production focused heavily on fighters to defend against bombing. Fighter production exceeded 33,000 aircraft. Another fighter-type production, more than 20,000. These fighters were necessary for homeland defense, but their production consumed resources that might otherwise have gone to bomber development or other military needs. The strategic implications were clear. Germany was fighting a defensive war in the air, attempting to destroy enough bombers to make the bombing campaign unsustainable. The United States was fighting an offensive war, producing bombers faster than Germany could destroy them, while simultaneously producing fighters to escort those bombers. The mathematics favored the side with greater industrial capacity. In late 1943 and early 1944, American escort fighters began accompanying bomber formations deep into Germany, further tilting the balance. German pilots attacking Liberator formations in early 1944 faced not only the bomber defensive firepower, but also escorting fighters that could outperform their fighters at the altitudes where bomber combat occurred. A pilot who survived defensive fire from the bombers then had to survive combat with American fighters during withdrawal. The cumulative risk became unacceptable. German loss rates climbed throughout 1944. During one concentrated series of bombing missions in February against German aircraft production facilities, German forces lost more than 300 fighters in 6 days of intensive combat. Many of these losses occurred during attacks on Liberator formations. The German fighter force never fully recovered. By June 1944, when forces invaded Normandy, German air forces could barely contest air superiority over France. The Liberator flew more than 200,000 combat sorties during World War II. It dropped more than 635,000 tons of bombs on targets. American bomber groups attacked oil refineries, aircraft factories, transportation infrastructure, and military installations across occupied Europe and Germany. The aircraft served in every theater of war from Europe to the Pacific to the Mediterranean to Asia. But the most significant contribution was perhaps not the bombs it dropped, but the industrial and tactical reality it represented. Each bomber in formation over Germany was physical proof of American production capacity. Each bomber carried 10 weapons, 6,000 rounds of ammunition, a crew of 10 men who had been trained at tremendous expense, fuel refined from American oil fields, bombs manufactured in American factories, and represented an investment of approximately $300,000 in 1944 currency. The Germans who faced these formations understood what they represented. They were not fighting individual aircraft. They were fighting an industrial system that could replace losses faster than those losses could be inflicted. They were fighting an economy that could train crews, produce aircraft, manufacture ammunition, and sustain operations across multiple theaters simultaneously. They were fighting a nation whose productive capacity exceeded the combined capacity of all opposing powers. For the German pilots who survived the war, the memory of attacking Liberator formations remained vivid decades later. Many described a specific moment of realization, not during any single dramatic battle, but gradually over weeks and months of combat, when they understood they couldn't win. The understanding came from cumulative experience. Another mission where the bombers kept coming despite losses. Another engagement where defensive fire damaged your aircraft. Another day when replacement aircraft arrived in your unit bearing unfamiliar faces because the experienced pilots were dead. Franz Stigler, the pilot who encountered his first Liberators over Bavaria in March 1944, survived the war with 28 confirmed victories. In post-war interviews, he described the progression of his understanding. Early in his combat career, he believed German pilots could defeat the American bombing campaign through skill and determination. After months of combat against Liberator and Fortress formations, he realized individual skill had exerted far less than industrial capacity and numerical superiority. By war end, he understood that Germany had lost the air war not through any failure of courage or tactical error, but through simple arithmetic. The Americans had more of everything, and no amount of bravery could overcome that disadvantage. The 10 weapon positions on each bomber were not revolutionary technology. The weapon had been designed 20 years before the bomber entered service. The powered turrets used electric motors and mechanical linkages that were well understood. The computing gun sights applied known principles of ballistics and mathematics. Nothing about the defensive armament was beyond German technical capability to produce. What Germany lacked was not knowledge, but capacity. The ability to produce 18,000 heavy bombers, while simultaneously producing fighters, tanks, submarines, artillery, and all the other weapons required for global war exceeded German industrial potential. The United States possessed this capacity and used it to overwhelm opposing forces through material superiority. The crews who flew these missions experienced their own revelations. Although of different character than German pilots, American air crews discovered that even with 10 weapons, even flying in tight defensive formations, they were not invulnerable. German fighters could and did shoot down bombers. Anti-aircraft fire could and did destroy them. Thousands of American airmen died aboard bombers over Europe. The survival rate for bomber crews completing a full tour of 25 missions in 1943 was approximately 25%, but crews also learned that their defensive firepower worked. Gunners who had trained 4 months on ground ranges discovered their weapons could drive off attacking fighters, could damage and destroy them, could protect their aircraft and their crewmates. The confidence this created sustained morale through desperate missions deep into Germany, where losses sometimes exceeded 10% of the attacking force. The story that began with a German pilot encountering his first Liberator formation ended not with any single dramatic moment, but with the gradual grinding victory of industrial warfare. The weapon positions were one small part of a massive military machine. Individually, they were simply guns in turrets. Collectively, thousands of aircraft flying hundreds of thousands of sorties. They represented the application of American industrial might to the problem of strategic bombing. German pilots who had confidently engaged bombers in 1942 found themselves overwhelmed by 1944 by numbers and firepower they couldn't match. The terror they felt was not the fear of any individual weapon, but the realization that they faced an opponent whose resources were effectively unlimited. Each bomber destroyed was replaced by 2 more. Each mission flown depleted irreplaceable German pilots, while American training schools graduated thousands of new crew members. The war had become unwinnable, and everyone involved knew it. The mathematics that doomed Germany were visible in every combat report. 10 weapon positions per bomber, 18,000 bombers produced, 180,000 defensive gun positions, flying missions across 3 years of war. The numbers were overwhelming not because any individual number was impressive, but because the aggregate represented industrial capacity beyond anything Germany could counter. By the time German pilots learned to fear those 10 gun positions on each bomber, it was far too late to matter. The outcome had been determined the moment American factories began producing bombers faster than German fighters could destroy them.